Well, it's Wednesday and I'm on my way back home. I'm probably on the airplane right about now. Hope all is well. I'll see you guys tomorrow. So let's begin lesson 3.7. So lesson 3.7 is going to be solving polynomial inequalities. So the way we're going to do it though is we're solving for x. So our answer is going to be an answer in interval notation. Easiest way to do it is for us to go ahead and put an answer on a number line. Okay, but before we do that, before we put our answer on a number line, we need to know what numbers to fill in. So the trick to this whole thing really is to go ahead and use our graphics calculator to graph it. Okay, so I'm going to go to y equals clear, and I'm going to put in two different things. I'm going to take a 2x to the third plus an x squared plus 6. And I'm also going to graph a 13x. Okay, I'm going to type both those into my calculator. Now when I graph it, I want to see where the first graph, the x cubed equation, is greater than or above the 13x. So we're going to get two graphs, we're going to compare them. We want to find out when this first equation is going to be above 13x. So let's go ahead and graph it and see what we get. Alright. Now, what happens is I'm probably going to have to change my window so I see a little bit more of it. I can squeeze it in, but I need to make it taller. So if I squeeze it in, I'll go to my window and maybe -5 to 5 and maybe a -20 to 20. Let me graph that again. Okay, that looks a little bit better. Alright. Now, I'd still like to know what's going a little bit more on the end, so let me go to my window again. Let's change the y to maybe a -50 to a 50. Graph it. Okay, that's what I want. Now, when is the curvy graph above the straight graph? Because that's a linear function, that's a cubic, okay? Well, it's going to be above it in this region here. So what I need to know is what are the x values where they intersect here and here. So let's go to our calculate and let's use our intersect button, okay? So second calc, I go to my intersect and let's find out where the first intersection is way over here, okay? So first curve, let's move my cursor way over there, enter, second curve, enter, guess. Alright, so they intersect at the point -3, -39. Okay, all we really care about is just the x value, -3. So on my number line, 0, -1, -2, -3, and I'm going to put a solid dot at -3 because it's going to be greater than or equal to it. So it equals it at -3 and it's greater than it all the way until this other point, which is, so let's find the other intersection point. Second calculate, let's find out where they intersect, and first curve, let's put it closer to that intersection point. Oh, right about there, and right about there, enter, guess, enter. Okay, my second intersection point is at 1/2, 6.5. But again, we're only dealing with the x values because we want to do an interval. So I'm just going to take my 1/2. Alright, so let's go 1, 2. So 1/2 is right there. So between -3 and 1/2, the cubic function is greater than the linear function. So what I'm going to do then is just shade in between. So these are all the values that will make this expression greater than this expression. Okay, now it seems like there might be another spot. So the curvy graph or the cubic graph is above or greater than the 13x in this area as well. So I need one more intersection point. Second, calculate. Let's go to intersect, enter, bring it over to right about there, enter, about there. Second curve, guess. So it's at 226. Again, we don't care about the y value. All we care about is the x value. So at 2, I'll have a solid dot. And then what happens is from here on out, the x cubed will always be greater than the linear function, the 13x. So my number line looks like this. Okay. So once it's on a number line, then it's pretty easy to put it in interval notation. So my solution is going to be these values. You're going to go from -3 to 1/2 union, because we're going to skip over and get this region, a 2 all the way to infinity. Bracket because it's a solid dot, bracket because it's a solid dot, parentheses because you can never get to infinity, so it doesn't include infinity. Okay, let's take a look at example 2. Okay, example 2 is a little different because it's been factored. So since it's been factored, we can actually find out where it's going to equal 0. So the way I do this problem, we don't need to graph it. It's a little bit different. I'm going to take each of these x plus 3, set it equals 0. I'm going to have a x plus 3 again equals 0 because I have a double root. I write it twice. X plus 3, x minus 2 equals 0, and x plus 1 equals 0. What I'm trying to do is get these particular, what I call border points, all right? So where it's going to equal 0. Now, obviously, x equals -3, x equals a -3, x equals a 2, and x equals a -1. Okay. All right, I have all of the values that make it equal to 0. So let's go ahead and put a number line down. We're going to have 0, -1, -2, -3. We're going to have a 1 and a 2, 3. So one of the things I'm going to do is I'm going to put open circles because I don't see an equal sign. There's no equal sign on the 0, so I'm going to put an open circle at -3. An open circle -3 again. So that's a double root. Something weird's going to happen there. Open circle at 2 and an open circle at -1. All right. Now what I need to do is find out when this is, what value. So one of the easiest ways to do it is to test it. So I'm going to test any point that's within these intervals. So technically I have 1, 2, 3, 4 regions. I've got 4 regions. I want to find out if a value in these regions will make, any x value in this region will make the expression be greater than 0. So the easiest one to test is 0. So let's test 0, okay? So if I let x equal 0, let's find out what happens. So we'll have a 0 plus 3 squared, 0 minus 2 times 0 plus 1. Will that be greater than 0? I don't know. Let's check it out. Got a 9 times a -2 times a 1. Is that greater than 0? Get a -18 is not. It's not greater than 0. So that means I do not want to shade this region. Okay? So now we could test the next region, but what happens on these things is they really do shade every other region. So if it didn't work here, it probably will work here, okay? All right, I'll test it real quick and I'll show you that if I use -2, let's see, clear. If I plug in -2, I'll go -2 plus 3 squared times a -2, subtract 2 times a -2 plus 1, I get an answer of 4. 4 is definitely greater than 0, okay? So that means I do want to shade this region, all right? So what about, say, 3? We can test 3. Plug 3 in to test that region. So if I plug in 3, I could go a 3 plus 3 squared times a 3 minus 2 times a 3 plus 1, and I get an answer of 144, which is certainly bigger than certainly bigger than 0. So I want to shade the region 3. So I want to shade this region here. Now what about negative 4? Okay, does negative 4 work? Well, I don't know. Let's try it. Okay, so let's plug in negative 4 and see if negative 4 works. Okay, plug it into the original. So I'm going to go, all right, parentheses, I'll go negative 4 plus 3 squared. Negative 4, subtract 2, and a negative 4 plus 1, and I get an answer of a, positive 18, so it does work. Well, that's kind of odd. We'd have a region, and then we have another region. Well, here's the trick. It will work most of the time. You will shade every other region. So you shade this region, you skip a region, shade a region, but since this is a double root, remember that's a double, happens twice, there's a region within it, so we don't shade that region, but then we shade that region, okay? Again, the trick though is to test points and find out which x values, when plugged into the original expression, will give me a value greater than 0, which would be any positive value. These are the ones. Now, interval notation, right? So let's put this answer in interval notation. So interval notation is going to be like this. I will go a negative infinity, comma 3, parentheses because it does not include 3, union, we're going to go from negative 3 to negative 1, but we're not going to include negative 3 or negative 1. So union will go then negative 3, comma, negative 1. Then we got to go to the next one. So union, one more union with a 2, comma, infinity. Now, none of these symbols are brackets because we don't include negative 3, negative 1, 2, or either infinity. So that's interval notation, and that's given it on the number line. All right, let's turn the page. All right, now in example 3. So first of all, let's find out where all the zeros are. So to find the zeros, let's factor. So first of all, to find the zeros, let's factor. Okay. So to factor this one, I'm going to rewrite this as an x minus 3x minus 1. Factor this one, we're going to have an x minus 5 and an x plus 1. Okay, what this tells me is a couple of things. It tells me I'm going to have border points, and those are the one on my number line. So border points, okay, number line, okay, number line. So we're going to have border points at 3, at 1, at 5, and negative 1, because those are the values that will make it equal to 0. So we're going to have border points at x equals 3, because that would make it 0, at x equal 1, because that would make it be 0. Now, this would be a 0 term, but you can't really have it equal 0, so it's a border point. It turns out to be like an asymptote, which means the graph would not exist at x equals 5, and we'd have one at negative 1, which really is an asymptote, which of course the graph won't happen at negative 1 either, because you'll have an asymptote. So when I put these in, 0, 1, 2, 3, 4, 5, 6, negative 1, negative 2, negative 3, I am going to have a border point at 3. So I have an equal sign here, so at 3 I'm going to put a solid dot. It can be solid dot because it equals 0 at 3. I'm going to put a solid dot at 1 because it will equal 0 when x is 1. Now I got to be a little careful, got to be very careful the next ones. Even though it says equal, it cannot equal 5. It cannot equal 5 and it cannot equal negative 1 because if it equaled 5 we would divide by 0. So at 5 we're going to put an open circle, and at negative 1 we're going to put an open circle because at negative 1 we divide by 0 and it can't. Now we've got all these border points, so we're going to have to go ahead and again test some points. So let's test. First let's test 0. 0 is the easiest one. Let's test x equals 0. So let's plug 0 into the original. So if I go back up to the original, put 0 in, 0 squared minus 4 times 0 plus 3 over 0 squared minus 4 times 0 minus 5, we really end up getting a negative 3/5, okay? This will be a negative 3/5 when I cancel all the zeros, right? Okay, now, is negative 3/5 greater than 0? Is this negative 3/5 when we plug it in greater than 0? No. So that means we do not shade 0, all right? Well, let's test another point. So let's test region 1. Let's test number negative 2. So I'm going to plug negative 2 in to my calculator. And what I want to do is I need to find out if the value, I'm going to plug in negative 2, if the value is going to be positive, because that's going to be greater than 0. So here we go, parentheses. I'm going to go a negative 2 squared minus 4 times negative 2 plus 3, okay, divided by parentheses. I'll have to do a negative 2 squared. Notice I put the negative 2 parentheses squared, so I squared the negative and the 2, minus 4 times negative 2, subtract 5, close parentheses. Okay, what do I get? An error. Wouldn't you know it? Okay, let's see what I did wrong. Oh, it doesn't like that other parentheses. Okay, delete that. Enter. There we go. So we get a 2.14. So when I plugged in negative 2, I get a positive value, which means I want to shade this region. So I go on, take and shade this region, okay? Now, how about the region between here? It doesn't work. How about 2? Okay, so this region doesn't work. Let's try 2. So I'll plug in 2 into my original, plug the value of 2 into my equation. So now let's let x equal 2. We already let x equal negative 2 and it worked. That was a yes. X equal 2, we'll put in our calculator. Okay. And I will go to parentheses. I'll go 2 squared minus 4 times 2 plus 3 parentheses divided by parentheses. I'll go 2 squared minus 4, plug in 2, subtract 5, and I get a positive value. Okay, so 2 works because positive value 1.11 is greater than 0. So I want to shade this region. Okay. So now let's check the next region. Okay. So let's check 4. I'm going to let x equal 4. Plug it into my calculator. It's much easier to put it in your calculator. Okay. So if I plug in my 4, I will have a parentheses 4 squared minus 4 times 4 plus 3 parentheses divided by parentheses 4 squared minus 4 times 4 minus 5, and I get a negative value. Kind of expected because remember we were talking about how it's usually every other region. So 4 did not work. I got a negative value, so I do not shade that. Now probably 6 will work, so that's a no. So let's plug in something in this region. Let's plug in 6. Let x equal 6, and let's see what happens. Probably is going to work. All right, parentheses. We're going to go 6 squared minus 4 times 6 plus 3 divided by parentheses 6 squared minus 4 times 6 minus 5 parentheses, and I get a positive value. So yes, that'll work. So let's shade everything in that region. Okay, and again, it really was every other region, kind of what I kind of anticipated. So now, interval notation, right? Interval notation would be from interval notation. I'm going to write negative infinity, comma, negative 1 parentheses, because it does not include negative 1, union with a bracket, 1 comma 2 bracket, union a parentheses 5 comma infinity, and that's the end. Okay, so we're not going to do 4. I'll save that one for when I come back. Let me double check the homework to make sure I don't have anything like that on there. Page 316. You never know, it might be your lucky day. I might cut it down a little bit. We'll see. Because these are kind of hard. These take a lot of work. 316. Alright, 5 looks great. I'm happy with 5, 9, 19. Let me check this 35. Yeah, don't do 35. You can take 35 out. And you can even take 27 out. How's that? So it's just 3 problems. 5, 9, and 19. Aren't you lucky? There you go. So I'll just do 5, 9, and 19. You can take a 27, 35. And we'll talk about example 4 when I come home tomorrow. So I'll see you tomorrow. Okay?